Alright, so this is my Lab 3 presentation, which is the magnetic field of a bar magnet for Physics 2212 Section P with Dr. Wise. So the purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet. In order to do this, we used the magnetometer app on our phones in order to measure the magnetic field coming from the bar magnet. And this magnetometer app was able to give us the separate x, y, and z component of the magnetic field as shown in microteslas. So the calculated value of mu was found using the following equation: k equals mu sub naught over 4 pi times 2 times mu. And I found mu to be 6.37222, so this is what I use for my code. And this equation here is the equation for the magnetic field, which is what I use in my code later on. So for some assumptions, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? I believe that our results would have been skewed as the Earth's magnetic field would have interfered with our magnetometer app and given us the wrong values. And if we were to stick two identical magnets together end to end and run the experiment again, I believe that our measurements would increase by a magnitude of 2, but the directions of the fields should be the same. And some other assumptions that we made are that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field would increase. And when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. So for the coding of this lab, first I input the value of the magnetic dipole moment that I calculated and set it as the mu mag variable. And then I created a function that would calculate the magnet's magnetic field. And this is from that equation earlier, the B equation. And so for my code, you can see here I have input my mu mag variable. Here's where I write my function for the magnetic field. I have my scale here. I have my distance here. And here I set up my axes for observation, just using distance. And then here in these two lines of code here, you can see that I'm creating two arrows for the field on axis, and then here these are for the perpendicular axis vectors. And it's not shown here, but I also did some for I did 4 vectors for 45 degrees off the axis. So yeah, after creating my function, I created the arrows to show the magnetic field, both on axis and perpendicular to the axis. And then to finish the code, I created 4 additional arrows to show the magnetic field 45 degrees off the axis. And you can see here's my code. Here is where the magnet is. These orange vectors here represent the magnetic field that is on axis. And these blue arrows here, as you can see, these blue arrows show the magnetic field as calculated perpendicular to the x-axis that we measured. And then in addition, I created 4 more vectors to help show the magnetic field at 45 degrees. So you can kind of infer that the magnetic field is kind of traveling like this from the magnet if you kind of follow the arrows, which is what's expected based on what we've learned in class. So yeah, that's it. Thank you for listening.